Hi kids, here I will be solving exercise 1.1 of class 10 mathematics of Ncert. So I will be covering all the questions of this exercise which is on page number 5. I will take every exercise in every video. So for further videos you may like and subscribe this channel Class at Bits, and I will solve all the questions here, and also I will discuss the topics. So let's start with this exercise 1.1. The first question, where we have to express each number as a product of its prime factors. So first number given is 140. What are the prime, what do you mean by prime factor? You have to show this number as multiplication of its prime factors. What are the numbers, the list of numbers that are divisible by this, that can divide this number 140. So 140, see, it's an even number, so it is divisible by 2. 2 sevens are 14. Again divisible by 2, 35. At the bottom we will write the quotient, and here we will write the term that will divide the number. So now 35. So which number can divide this 35? So 5 is one such number that can divide 35. 5 sevens are 35. Can 7 be further divided? No, since 7 is a prime number. So if I want to write 140 as the product of its prime factors, so 140 is 2 raised to the power 2 into 5 into 7. Next, we take the number 156. 156. So this is an even number. So divided by 2. 2 sevens are 14. 2 8s are 16. Again divide by 2. 2 3s are 6. 1 2 9s are 18. This number is divisible by 3. 3 1s are 3. 3 3s are 9. So this number 156 can be written as 2 raised to the power 2 into 3 into 13. This is the prime factorization of the number 156. Now going to the next number, that is 3825. So this number, third number. So this number 3825, at the first glance we get to know that this number is divisible by 5, because the last number, the unit digit of this number is 5. So again we will draw the table and divide it first of all with the number 5. So 5 sevens are 35, 5 6 are 30, 5 5 are 25. Again the unit digit is 5, hence this number is divisible by 5. So 5 1s are 5, 5 5s are 25, then 5 3s are 15. 153. This number is divisible by 3. How did I say that this number is divisible by 3? Because the summation of this number is 5 plus 1, 6, 6 plus 3, 9. The summation of each digit of this number is divisible by 3. So 5 plus 1 is 6, 6 plus 3 is 9. So this 9 number is divisible by 3, and hence this number is divisible by 3. So 3 5s are 15, 3 1s are 3. Again 5 plus 1 is equal to 6, which is divisible by 3. So we can divide this number again by 3. 3 1s are 3, 3 7s are 21. That's it. So now 3825, the prime factorization of this number 3825 is 5 raised to power 2 into 3 raised to the power 2 into 17. So the better way of writing this is 3 raised to the power 2 into 5 raised to the power 2 into 17. I have just reordered the writing of these numbers. Now the next number is 5005. As in the first glance itself we get to know that this number is divisible by 5 because the unit digit is divisible by 5. So 5 1s are 5, so 1001. Then again 1001, which number we can use to divide this number? Not 2, not 5, not 3. So we can try the number 7. 7 7 ones are 7, 8 9 10, so 30, 7 fours are 28, 29 30, 7 threes are 21. Now can I further divide this number 143? Observe, we can say that this number is divisible by 11. So 11 ones are 11 and 11 threes are 33. So this 5005 we can write as 5 into 7 into 11 into 13. Now going to the next number, which is 7429. So 7429, we can divide this number by 17. So 17, and we get here 437. Now again divide this number by 19. And this is a prime number, cannot be divided further, hence 7429 we write as 17 into 19 into 23. This is the prime factorization of the number 7429. Now going to the next question of this exercise 1.1. So find the HCF and LCM of the following pairs of integers and verify that LCM into HCF is equal to the product of the two numbers. So here the first part of this question, second question is 26 and 91. 26 and 91, and we need to find the HCF and LCM of these two numbers. So for that we will have to find the prime factorization of both the numbers. So I will draw this table for both the numbers 91 and 26. So it is divisible by 2. So 2 into 13. So 26 we can write as 2 into 13. Then we have 91, which is divisible by 7. 7 ones are 7. 7 threes are 21. Hence the 91 can be written as 7 into 13. The first number and the second number. Now if I want to know the HCF of these two numbers, HCF. So HCF is the lowest power of the common number. There is only one common number here, 13, and the lowest power is 1. So HCF is 13. And LCM, all the numbers possible. So 13 is one number common to both. Then there is 2 and 7. So LCM should be 13 into 2 into 7, which is 26 into 7, 182. And here we need to, the second part of the question is that we need to verify that the product of the numbers is equal to the product of HCF and LCM. So 26 into 91, I am using calculator beside me. 26 into 91 is 2366, and this 182 into 13 is 2366. Hence it is verified that both the sides are equal. Now moving to the next question, the next part of this question 2, 510 and 92. So 510 and 92. So for 510, Then this number is divisible by 3. Summation of the digits of the number is divisible by 3. Hence 9, 3 4s are 12. Again the 34 number is divisible by 2. It is an even number. 2 1s are 2, 2 7s are 14. Now it is further not divisible. 17 is a prime number. Hence 510 can be written as 2 into 3 into 5 into 17. Now 92. So this number is divisible by 2 because of it being even number. 2 4s are 8, 1, 2 6 are 12. Again divisible by 2, 2 3s are 6. Now 23 I believe is a prime number. So 2 raised to power 2 into 23. Now to write the HCF, we will take the lowest power of the common number. The common number is 2, the lowest power is 1. So HCF is 2. LCM of these two numbers is 2 raised to the power 2 into 3 into 5 into 17 into 23. All the numbers possible. Which is a big number. 2 3 4 6 0. No point of checking by multiplying the numbers. So here it will be equal only. The summation of the two numbers and the product of the two numbers A and B will be equal to the product of the HCF and LCM of those two numbers A and B. Now going to the next part, which is 336 and 54. 336 and 54. First of all, find the prime factorization, simplest part of the question. This is divisible by 3. Then again this is divisible by 2. The unit digit is 2. 2 5s are 10. 2 6 are 12. Again divisible by 2. 2 2s are 4. 1 2 8s are 16. Now can I divide it further? No. So this 336 can be written as 2 raised to the power 1 2 3 4. 2 comes 4 times into 3 into 7. Now 54 divide by 2. 2 2s are 4, 1 2 7s are 14, 3 9s are 27, 3 3s are 9. Can it be divided further? No. Hence we write the prime factorization, 2 into 3 ki power 3. So what is the HCF here? Lowest power 2 into 3. 2 into 3 is 6. And what is the LCM here? Many numbers are there. 2 raised to the power 4 into 3 into 7. Which will be, since the 21 into 16. 21 this is 336. Which is not correct. So 2 raised to the power 4 into 3 raised to the power 3 into 7. So 336 into 9. Which 9 6 are 54. So we can see that it satisfies that thing, that the product of the two numbers A and B is equal to the product of the LCM and HCF of those two numbers A and B. Now proceeding to the next part is third question. Find the HCF and LCM of the following integers by applying prime factorization methods. So here we have set of 3 numbers. So now I will be solving the third question. First part of the third question. 12, 15 and 21. So the prime factorization of 12 is 2 2s are 4, 4 3s are 12, 2 square into 3. Prime factorization of 15 is 3 into 5. These are very small numbers, so I can write directly. If you want, you can create that table and keep multiplying, and then can arrive to this point where I write these prime factorizations directly. So 21 is 3 into 7. 3 7s are 21. So now here the HCF will be, see the common number. Is there any common number? No. 3 is common. So 3 is the HCF. Is there any LCM to it? 2 raised to the power 2. Put all the possible numbers. 2 raised to the power 2. Then there is one 3. Then 5. Then 7. Any other possibility? No. So this is the LCM of the number. You can multiply it if you want. The second part is finding the LCM and HCF of 17, 23 and 29. 17, 23 and 29. So here 17 is a prime number or composite number. So 17 is a prime number. So no prime factorization possible. It's only 1 into 17. So effectively there is no prime factorization of it. 23 is also a prime number and 29 is also a prime number. So we are trying to find the HCF and LCM of 3 prime numbers. So in such case HCF is 1. There is no common divisor to these 3 numbers, and LCM is the multiplication of these 3 numbers itself, 17 into 23 into 29. Now third part is 8, 9, 25. So 8 का है, so 8's prime factorization is 2 raised to the power 3. 9 का है 3 raised to the power 2, and 25 का है 5 raised to the power 2. Is there any HCF, any common divisor? No. LCM, is there any common? So LCM is the multiplication of all the numbers, since the HCF is 1. So the multiplication, the LCM will be 8 into 9 into 25. Okay. Now going to the next part, the fourth question. Given the HCF of 2 numbers, find LCM of those 2 numbers. It's an easy question. You just need to know the multiplication and division. The fourth part is HCF of 306 and 657 is 9, and LCM of 306 and 657 we need to find. So as per formula, H into L is 306 into 657. H is 9, this is 9, so LCM will be 306 into 657 divided by 9. 3 3s are 9, 3 1s are 3, 3 0s are 0, 3 2s are 6, again divide 3, 3 3s are 9, 3 4s are 12. So you get 34 into 657. So this is the LCM of the numbers, 34 into 657. Which is a big number, 22338. Hence this is the answer. Now the next part is the fifth question, Check whether 6 raised to the power n can end with digit 0 for any natural number n. Check whether 6 raised to the power n can end with the digit 0 for any natural number n. So power, in case of powers, when we put power to a number, the unit digits are repetitive. After a point they form a cycle. For example, if I write 6 raised to the power 1, then it is 6. 6 raised to the power 2 is 12. No, 6 raised to the power 2 is 36. Then 6 raised to the power 3 is 216. Now 6 raised to the power 4 is 1296. Now 6 raised to the power 5 is 7776. We can see that every time the unit digit is 6 itself. If we find further power 6 raised to the power 6, 6 raised to the power 7, we will find that every time the unit digit will be same 6. So there is no possibility that the unit digit of a power of this number will be 0. And hence this number 6 raised to the power n can never end with the digit 0 for any natural number n. Now the next part, sixth question. Explain why these two numbers are composite numbers. So these two numbers are 7 into 11 into 13 plus 13, and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. We have to tell why these two numbers are composite numbers. So here the best way is, in the first case, see, just take a number 13 common. So 7 into 11 is 77 plus 1, since we have taken the 13 common. So it is 13 into 78. This number is 13 into 78. So this number is divisible by some number other than 1 and itself. Hence this is a composite number. Same for the second number. Take a number 5 common. So 7 into 6. Instead of writing into, I am writing dot. 1, 4, 3, 2 plus 1. So some number and 5. Again this number, the second number, is divisible by 5 other than 1 and the number itself, and hence this is a composite number. So both the numbers are composite because they are divisible by some number other than 1 and itself. Now the next question is seventh question. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field. So there is a circular path. I'll draw while I read the question. So the Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So here we need to take LCM of these two numbers, 18 and 12. Question is after how many minutes they will meet again at the starting point. So to find the LCM we need 18, 12 prime factorization. So 2 into 3 square, 3 and 9 is 18. 2 into 2 square, 22 into 4, 4 3 are 12. So it's 2 square into 3. Fine. So the LCM is 3 square into 2 square. 9 into 4 is 36. So after 36 minutes, these two will meet. Okay, in the next video, I will start with the next exercise 1.2. And if you want to watch solutions of further exercises of class 10 NCERT mathematics, then please follow and subscribe. Follow this channel and like these videos. Okay, thank you.